In stats today, we looked at how to construct a one proportion confidence interval. So we are starting out on this lesson looking at the four-step plan or four-step process in constructing an interval. And one way to think about it is it's almost like writing a research paper, or whether you're conducting an experiment or writing some kind of formal essay. We want to do 4 steps, including all the points that you see in there. So you can't see the 4th step, conclude, but we want to start with the state step, and this is kind of like your title. You are talking about what you're estimating. So on this set of notes, see at the very top, we're talking about proportions. So typically on the state step, I start by saying something like true P, true proportion of and then we have some context, whatever the situation. You'll see one in just a second. In the next handout, we will do a one sample confidence interval for means, so I'll lead with the Greek letter mu and say true mean of. So typically on that first step, the state step, I lead with either true P, true proportion of, or mu, true mean of. And this handout will all be proportions. When we move to the next chapter, we'll add to the state step and we will put in some hypotheses. To be honest, you just need to put all of these items on your paper. They don't necessarily have to be in order. For example, I learned this step right here later in the process in our calculation part. Now, according to the textbook, it should be up in the plan step, but I typically write the name of the confidence interval that I'm constructing down where I'm doing all the math. And up on the plan step, let me get rid of that arrow. Now, it doesn't matter. You can put it in the plan step. I'll find it. I'm going to search through your work and give you credit if I see it anywhere. You need to somewhere note that a random sample was taken, or maybe treatments were randomly assigned. And if it's not typed, then you just assume that it was the case. But you do have to acknowledge that randomness was important. Large counts, that's off of last chapter for proportions. Remember, if this checks out, we have an approximately normal sampling distribution. The problem with last chapter's rule is we're estimating P up here with P hat. All we have is P hat. So let me write what I just said. Estimating P with P hat. We have no idea. We don't even have a claim for the true proportion. So down there on the large counts, we don't know what P is. So we're going to make do in this chapter with P hat. It's almost identical to what you memorized last chapter. And then the next rule is something you hopefully memorized last chapter, and it's the 10% rule. N needs to be smaller than 10% of the population, which, to be honest, on these problems, I rarely even check that because it seems to always be true. You don't want to totally ignore this 10% rule right here. It's important, but I usually don't even write it down on these FRQs. The time when it does come into play is whenever they ask a question like, why can we not calculate a confidence interval? And sometimes it's because that rule is broken. Okay, moving on, the do step. This is where all the math happens. Your calculator will do most of it. On your formula sheet, it says this. This is all that's typed on your formula sheet. And off of what I talked about last week, this portion is called the margin of error. I mentioned that last week. So if you multiply the critical value and the standard error by each other, you get the margin of error. Critical value, this is always going to be Z or T. We're used to working with Z. We've been using Z, the bell curve, all year long, and we'll continue to use it with proportions. But T is going to come up in the next handout when we start estimating mu, the true mean. So we'll talk about T down the road, but for proportions, we will always use Z. Once again, we're estimating P with P hat, so our statistic is P hat plus or minus Z, and then you memorize this last chapter, P times 1 minus P divided by N. Except we don't know what P is, so we are going to make do with the standard error, P hat. That is on your formula sheet. If you flip to page 2, very, very top, it's up there. All right, lastly, we will interpret the interval. We've been practicing that. Hopefully you already know what that is. All right, let's try a full problem. Let's give this a try. So there was a problem in the textbook that talked about beads in a container. Mr. Vignoli's class, they have a container. And there are some red beads and white beads in there. They need us to take a sample, or they already took a sample, construct and interpret the true proportion of red beads in the container. So before we get all formal, notice this is our total. That's capital N. That is not the sample. This one, they didn't even tell us what the sample was, but they did tell us how many red and how many white. So we're assuming the sample is red plus white. So 251. All right, let's move on. So I'm going to write state. You don't have to write state, plan, do, conclude, but I will on these first few problems so you can see some organized thoughts. We're estimating P, the true proportion and then skim through the paragraph. What are we estimating? And it is usually typed right here. True proportion of red beads in a container. And I guess we should say where this container came from. In Mr. Vignolini's class. And that's our title, that's our state step. In the plan step, I talk about a random sample and the large counts. So I'm skimming through there. I don't see anything about randomness. I do see my sample size is 251, which was 107 plus 144. I do see that P hat, we're interested in red beads, is 107 divided by 251, which happens to be 0.4263. But I don't see anything about randomness. So I'm just going to write assume a random sample was taken. You got to show that the large counts checks out. So in p hat greater than 10, in 1 minus p hat greater than or equal to 10. And we see right away it checks out, right? Let's change colors. Isn't this number n times p hat? And this number is n times the complement? If you don't see it, let's do it. But by the way, if they ever print it that way, you can skip this middle step. 251 times 107 divided by 251. Don't those cancel out? If they ever tell you the number of successes, you don't have to show all the work. You can just write 144 is greater than 10. Make sure you say what that implies. Sampling distribution is approximately normal. The 10% rule, that third thing, n needs to be smaller than a tenth of the population. 251 is smaller than a tenth. And that, I mean, write it down if you want, but I usually just do a little mental check on that and move on. I only check randomness and the large counts. I typically write the name of the interval on the do step, but you are welcome to write it up there on the plan step. And while I typed the name, let's find it on the calculator. Because some people can't remember the name, and they're all typed for you on the calculator. Press Menu, Stats. We're doing confidence intervals, so go down to confidence intervals. And you just need to find the right one. I know we don't have two samples, so that leaves us with one prop z, or t, or z. Hopefully you know it's not t, because I already told you we always use z with proportions. You're down to z or one prop z, and hopefully you pick one prop z, because we have a proportion. If you click this one, you'll see right away it's the wrong one, because I don't have sigma or x bar. That's the wrong choice. So feel free to hunt around, and with some trial and error you find it, and we want one prop z interval. So back on here, I write one prop z interval. You can just copy it from the calculator, and that is p hat plus or minus z and then we're going to go to the calculator. I'll tell you where z and all that comes from. Well, you know where p hat and n come from, but I'll tell you what's going on with z here in a second. Let's look at the calculator, though. So we have 107 red. Notice that needs to be a whole number. And 251 total beads in the sample. Back to the problem. They ask us for a 95% interval. So keep that at 95. And you're good to go. They even give you the margin of error on the Inspire. They give you p hat. We want these two numbers. Make sure you write down lower to upper. Don't write the big one first. That doesn't make any sense. So we are going to say our interval is 3651 to 4875. And if you're confused right now on the z-score that we're using and the confidence interval, think of the bell curve. And what we're doing is we're looking at the middle 95%. And that precise z-score is 1.96. Negative 1.96. If you ever want to get the level, the critical value outright, you go to inverse norm. But you got to be clever because this one's the percentile. Remember this area to the far left over there? This is 0.025 area. So if I was to do inverse norm, that'd be 975 percentile. And that'll give me a z-score of 196. You don't have to do that, but it is kind of handy to be aware of all the details of this thing. I'll show you another way to find the z-score in the next video, but let's wrap this one up. Let's do conclude. We've been practicing this. We have 95% confidence. That the true proportion of red beads in the container that's ugly. Is within 0.3651 and 0.4875. All right, see y'all later.